Hello there, and welcome to the Sleepless Scientist, a quiet little corner of the internet where curiosity puts on its comfiest slippers and science becomes a soft lullaby for your mind. Tonight, we're going to drift together into one of the most fascinating questions of all. What is time, really? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Maybe you're curled up under a warm blanket, the day finally loosening its grip. Or you have a soft lamp glowing beside you, a cup of tea cooling quietly in your hands. However you've arrived here, you're in exactly the right place. Time slips past us in so many ways, measured in the familiar rhythm of your heartbeat, the ticking of your watch, the way the light changes in a room as the day becomes night. Sometimes it feels fast, sometimes it feels endless. And sometimes, when you pause to really think about it, time feels almost impossible to pin down at all. Over the next little while, we won't try to solve every mystery. Instead, we'll explore the science, the philosophy, and the quiet wonder of what it means to exist inside something that never stops moving. We'll look at how time shapes the universe, how it bends and stretches, and how it leaves its traces in everything we do. If you find tonight's exploration calming or thought-provoking, I'd be so grateful if you'd give the video a like or subscribe to the channel. It helps this gentle community grow and makes it easier for others to find a peaceful moment here too. So, whenever you're ready, take a slow breath in and out. Let your shoulders soften. Let your thoughts quiet. Tonight there is no rush, no deadlines, no need to be anywhere but here. Just you, this small stretch of time and the hush of curiosity. Let's begin. If you've ever waited for a pot of water to boil, or watch the last few minutes of a workday crawl across the clock, you know that time has a peculiar way of changing shape when you're paying attention. A minute can feel like an hour, and an hour can slip by like the turn of a page. In our everyday lives, time is not some uniform stream we simply drift along. It's more like weather, changing, unpredictable, shaped by our feelings and our focus. You might notice how, when you're absorbed in something you love, a long walk at dusk, a favourite book, a conversation that unspools effortlessly, time seems to fold itself neatly away. Hours pass, but you don't feel them stacking up. And then, in moments of discomfort or anticipation, each second seems to announce itself, one after another with a kind of stubborn clarity. You can almost hear them ticking. The seconds before the dentist calls your name, the slow crawl through a traffic jam, the hush before you open a message you're afraid to read. Psychologists have tried to understand why time feels so fluid to us. One idea is that our perception of time is deeply tied to attention. When you focus closely on what's happening, you tend to notice every detail. Your brain builds a richer, denser memory of that moment, and afterward, it feels longer in hindsight. That's why novel experiences, a trip to a new city, the first day in a new job, even something as simple as rearranging a room, seem to expand time. They fill it up with impressions your mind hasn't catalogued before. Contrast that with routine. When your days follow the same familiar patterns, same commute, same meals, same conversations, your brain doesn't bother to note every detail. It compresses the experience, smoothing it over like a well-worn path. In the moment, time feels ordinary. In memory, it contracts. Some researchers call this the holiday paradox. While you're on vacation, days feel long because everything is new. But when you look back, it feels as if the trip flew by. Your brain saves the highlights, but discards the gaps. There's also a curious link between age and the pace of time. As children, each year is a huge portion of your life, a collection of firsts. First snow, first school, first heartbreak. Time stretches out, generous and wide. But as adults, the years start to blend. You've already learned the seasons, the rhythms, the patterns. A year becomes just another repetition, and so it seems to pass more quickly. When you think about it, time is the backdrop of every ordinary moment. Your morning coffee cooling as you scroll through the news, the steady drift of daylight across the kitchen floor, the way your heartbeat slows as you settle into bed. We don't often stop to consider how remarkable it is that we can feel time passing at all. That in the middle of our busy lives, something as abstract as a minute can take on texture. Fast, slow, bright, dull, just depending on how we're paying attention. Tonight, as you rest here, maybe you'll notice time shifting too. The minutes of this story stretching out, soft and unhurried, giving you space to breathe. There's nothing you have to do, nowhere you have to be. Just you and this quiet evening and time moving gently around you. While the seconds on your watch tick along in perfect, impartial rhythm, your body keeps time in more personal ways. Tucked deep inside your brain, near where the optic nerves cross paths, sits a tiny bundle of neurons called the suprachiasmatic nucleus. It's a mouthful of a name for something so small, but it plays an extraordinary role. It's your body's master clock. This little cluster of about 20,000 neurons works like a conductor, keeping your biological rhythms in sync with the world outside. Each morning, as daylight slips past your eyelids, signals travel to this clock, reminding it where the sun is. In turn, it orchestrates the rhythms that make you feel alert by day and sleepy by night. This rhythm is called the circadian cycle, circa, meaning about, dies, meaning day. Roughly 24 hours long, give or take a few minutes, it guides countless processes inside you. Your body temperature rises and falls, hormones surge and ebb. Your blood pressure shifts, your digestion speeds up or slows down. Even your mood can trace some of its highs and lows back to this quiet ticking inside your cells. You may have felt this clock in action when you've travelled across time zones. Jet lag isn't just tiredness, it's your circadian rhythm trying to catch up with the sunrise. Your body insists it's still night, even when the airport windows show a bright morning sky. It can take several days for this internal clock to adjust, 1 hour per day, like a careful negotiation between biology and geography. Your cells, too, keep their own time. Almost every organ, your liver, your skin, your muscles, has its own smaller clock, humming in harmony with the master clock in your brain. It's an astonishing feat of coordination, a quiet symphony that has evolved over millions of years, so that all the tiny processes that keep you alive unfold in careful sequence. But your biological clocks don't just follow light. They listen to other cues too, when you eat, when you move, when you rest. That's why working the night shift can feel so disorienting. Even if you draw the blinds and try to sleep by day, your body still remembers that the world is lit up outside. It whispers to you that you ought to be awake. Interestingly, some creatures have clocks tuned to very different tempos. Arctic animals, who live in months-long darkness or daylight, adjust in ways scientists are still trying to understand. Plants open and close their leaves with the sun. Coral reefs release their eggs and sperm in synchronized waves, guided by moonlight and tidal rhythms. And even here in your own life, you can feel your clocks at work. The gentle pull towards sleep each evening, the surge of alertness mid-morning, the slump of drowsiness in the afternoon. These are the rhythms that keep you connected to the turning of the earth. So tonight, as you lie quietly in your chosen corner of the world, your own internal clock is ticking along, marking the passage of time in ways no watch could ever record. It doesn't need batteries or winding, it doesn't forget, it simply keeps time with you, every hour, every day. A silent companion, reminding you that even while you rest, you are part of something ancient and beautifully precise. If you close your eyes and think back to your earliest memory, you'll notice how time softens the edges. The moment is there. Perhaps a birthday candle, a favourite toy, a bright afternoon. but it feels a little blurred, like a photograph that's been handled too often. Memory is the way your mind stitches time together. It takes the raw, flowing stream of moments and gathers them into something that feels continuous, something that feels like a story. In many ways, your memories are the only reason you experience time as moving forward at all. Without them, every instant would be just a flicker, unanchored to anything before or after. This is what scientists call the psychological arrow of time. While the physics of time can be symmetric, some equations work just as well moving backward. Your mind insists on a single direction. You remember the past, you anticipate the future, but you can only ever stand here, in this present moment, watching one side slip into memory as the other side emerges in front of you. Researchers have found that this forward drift is tied to how your brain encodes experiences. When something happens, a sound, a sight, an emotion, your brain lays down a trace, a pattern of connections that preserves the experience in a way you can recall later. The hippocampus, a seahorse-shaped structure deep in your brain, acts as a kind of librarian, cataloguing these memories so you can find them again when you need them. Sometimes you might feel as though you're moving through time at a steady pace, but in truth, your memories are always shaping that perception. Think of a day when you did something completely new. Maybe you moved into a new home, or travelled to a place you'd never been. Those days feel long and vivid because your brain was busy capturing so many unfamiliar details. And then there are the days that blend together. A week of familiar routines, similar meals, the same commute. In memory, they compress into something small, almost weightless. That's why, when you look back, whole months can feel like they passed in the span of a single breath. This isn't just a quirk, it's a feature of how we evolved. For most of human history, remembering where you found food, which paths were safe, who could be trusted, these were the things that kept you alive. Your mind became a careful curator of useful moments, tagging them as important or forgettable. And yet, for all the ways memory helps you navigate the world, it also gives time its bittersweet quality. You can replay a moment you love, but you can't step back into it. You can recall the feeling of a summer evening, the warmth, the sound of crickets, but it always stays just out of reach. Memory is a window, but it only opens in one direction. Even now, as you listen, your brain is recording the rhythm of these words, the hush of the room around you, the quiet sense of being here in this particular night. Later, you might remember it as a small, comforting pause, a pocket of time where nothing else was required of you but to rest and be. So while the universe may not prefer any one direction for time, your mind does. It carries you forward, moment by moment, collecting the echoes of your days, and in that gentle collecting, time becomes something you can hold, something you can call your own. You've probably noticed how time can speed up or slow down depending on how you feel. A joyful afternoon can vanish before you're ready to let it go. A moment of fear can stretch itself thin, expanding each heartbeat into something that feels like an hour. Scientists have been curious about this strange elasticity for a long time. In the laboratory, they've shown that when people are afraid, their sense of time can lengthen dramatically. One famous study asked participants to look at numbers flashing on a screen while dangling high above the ground on a terrifying drop ride. When it was over, the riders consistently overestimated how long the fall had lasted. Your brain does this because, in moments of threat, you need more information. Your attention sharpens, your awareness expands. The amygdala, the part of your brain responsible for processing fear, steps in and boosts the vividness of your memories. Later, when you look back, all those extra details make the experience feel longer than it was. It's not just fear that changes time, anticipation does it too. Think about waiting for news, an important test result, a phone call, a message that will decide what happens next. In that waiting, minutes can feel endless. You might pace across the room, check your phone again and again, your mind rehearsing every possible outcome. In a way, your brain fills the empty space with imagined futures, and each one takes up just a little more time. Then there are moments of flow, when you're completely immersed in something you love. Maybe it's cooking, or painting, or solving a puzzle. During these times, your sense of self seems to fade into the background. Time flattens, smooth and effortless. Hours can pass in what feels like a single, continuous breath. This state of flow is a curious blend of intense focus and quiet contentment. The psychologist Mihaly Csikszentmihalyi, who coined the term, described it as being completely involved in an activity for its own sake. When you're in flow, you're not measuring time, you're living inside it. Our emotions, it turns out, are powerful timekeepers. They shape the texture of each moment. Happiness makes time light and fast. Boredom slows it down, stretching it into long, empty corridors. Anxiety breaks time into small, jagged pieces, and sadness can make the hours heavy, reluctant to move at all. Even memory is shaped by this emotional lens. You remember the bright, joyful days more clearly because they mattered to you. You remember the frightening ones because they kept you safe. Neutral moments often fade into the background, absorbed by the steady rhythm of ordinary life. Tonight, as you listen, perhaps you'll notice your own sense of time softening. Without urgency or expectation, each minute becomes a little more spacious. There's no need to rush to the next thought, the next obligation, the next day. You can simply be here, letting your mind drift across the quiet landscape of these ideas. Because in the end, time isn't only measured by clocks or calendars, it's measured by feeling, by the weight and colour and shape of each experience. And sometimes, the most generous thing you can do is allow yourself to notice it. If you've ever wondered why a watched pot seems determined never to boil, you've experienced one of time's simplest illusions. When you focus all your attention on the passage of time, you make it feel longer. The seconds don't change, but your awareness of each one grows sharper, like a magnifying glass held over a page. Psychologists have created many experiments to explore these illusions. In one classic study, volunteers were shown a series of identical images. Every so often, the researchers would slip in a slightly different picture, a shape tilted at a new angle, or coloured differently. The first time the new image appeared, participants said it lasted longer, even though it was displayed for the exact same duration. This effect is called temporal dilation, and it happens because your brain is startled by novelty. Imagine walking into a familiar room and seeing something out of place. A red umbrella propped against a chair, a suitcase that wasn't there before. For a moment, time feels as if it has expanded, making room for you to notice what's changed. Another illusion you may have felt is called the chronostasis effect. The next time you glance at a clock with a sweeping second hand, watch closely. You may notice that the very first tick seems to last just a little too long. That happens because in the instant you shift your gaze, your brain pauses the incoming visual information and stitches together the moment before and after the eye movement. To keep your experience seamless, it fills in that gap with an extended impression of the first tick. It's a small reminder that your experience of time is always being constructed behind the scenes. You never really perceive time directly. You perceive a story your mind is assembling in real time, blending sensation, memory, and attention into something that feels continuous. Even something as ordinary as your heartbeat can shape this perception. Research has shown that your internal rhythms, the pulsing of your blood, the pacing of your breath, act as quiet metronomes. When your heart speeds up, time can feel more urgent. When your breath slows, time softens and opens like a window letting in fresh air. Some illusions of time are stranger still. There are people who experience tachypsychia, a temporary distortion often reported in emergencies or accidents. They describe events happening in slow motion, as if the world has dropped into a deeper gear. Scientists believe this is because the brain is recording so much information that, in retrospect, the event feels longer. You don't have to face an emergency to notice how flexible time can be. A peaceful hour spent in a sunny corner with a book can feel rich and expansive, while the same hour in a waiting room seems to tighten into a series of impatient glances at the clock. And yet, even these illusions serve a purpose. They help you adapt. They keep you safe, aware, responsive. They remind you that time, for all its objectivity, is also a personal experience, shaped moment by what you notice, what you feel, and what you expect. As this first part of our journey draws to a close, perhaps you can feel time loosening its hold. The minutes here aren't in any hurry. They don't need to be counted or compared. They can simply pass, quiet and unmeasured, like ripples in a pond. So take a breath. Let the illusions fall away. For now, there is only this gentle moment, and all the soft, unseen clocks ticking quietly inside you. Before we discovered how flexible and relative time can be, most people thought of it as something solid, dependable and absolute. For centuries, time was imagined as a perfectly smooth river, flowing at the same speed everywhere, unchanging and universal. One of the first thinkers to give this vision its most elegant form was Isaac Newton. In the late 1600s, he imagined the universe as a vast, orderly machine, sometimes called the clockwork universe. To Newton, time was like the steady ticking of an enormous cosmic clock, independent of the things happening inside it. In Newton's equations, time exists in the background, the same for everyone, no matter where they stand or how fast they're moving. He called it absolute time, and it provided a kind of scaffolding for everything else: motion, gravity, collisions, the orbits of planets. You can picture it like a giant stage on which all the actors, planets, stars, apples falling from trees, move and change. But the stage itself doesn't bend or shift. Time, in Newton's view, was so reliable that you could set your watch by it, confident that every tick matched a tick anywhere else in the cosmos. This idea made sense for the world people could observe. After all, the motions of everyday life seemed perfectly predictable. If you tossed a ball, it followed a smooth arc. If you swung a pendulum, it kept time in even beats. Newton's laws described these patterns so accurately that they guided scientists and engineers for over 2 centuries. In this clockwork universe, past and future were laid out in a single, continuous flow. If you knew the position and speed of every object, you could calculate exactly where it would be at any moment in the future, or where it had been in the past. This way of thinking gave rise to what some philosophers later called determinism, the idea that the future is already contained in the present, if only you have enough information to predict it. Of course, in daily life, we rarely think about time as something we can calculate. But even today, the echoes of Newton's vision are all around us. We see them in the precise swing of a grandfather clock, in the mechanical gears that keep traditional watches ticking, in the dependable way the Earth circles the sun. Newton's laws worked so well that no one seriously questioned them, until people started looking more closely at light, electricity, and motion at extreme speeds. Little by little, experiments began to show that time wasn't quite as simple as it seemed, that perhaps the cosmic clock didn't tick exactly the same way for everyone after all. But before we leave Newton's orderly universe behind, it's worth pausing to appreciate how profound his insight was. In an age when many believed that nature was unpredictable and capricious, Newton showed that the world followed hidden patterns that could be measured, tested, and trusted. Even as you sit here now, listening in the quiet of your evening, you are sharing the same flow of time Newton imagined. The seconds pass steadily, counted by your heartbeat, marked by your breathing. And yet, as you'll soon see, this familiar rhythm is just one way of understanding time. Because in the centuries that followed, new ideas would emerge, ideas that would bend and stretch the very fabric of time itself. Imagine standing by a quiet railway track at night, watching 2 lamps placed far apart. one at each end of a long empty train car. If both lamps flash at the same instant, you would see their light reach you together. You'd say, without hesitation, that the flashes were simultaneous. But what if you were riding inside the train, moving smoothly past the station? As you passed the midpoint between the two lamps, they would flash again. This time, though, you'd be in motion, carrying your perspective along with you. To you, one flash might reach your eyes just a fraction of a second before the other. That's a thought experiment Albert Einstein often asked people to imagine. It feels like a simple puzzle. 2 lights, 2 observers. But hidden in this example is something revolutionary. The idea that simultaneity depends on where you are and how you're moving. Before Einstein, everyone assumed that time was the same everywhere, that a moment here was the same moment there. But in 1905, Einstein proposed something astonishing. He suggested that no 2 observers, moving at different speeds, would necessarily agree on what now means. In his theory of special relativity, time itself becomes woven, together with space, creating what he called spacetime. It's a little like discovering that the stage you thought was solid and flat is actually made of soft fabric, stretching and shifting beneath your feet. If you move differently, the fabric curves differently around you. To understand this, think again of the train. Someone on the platform and someone riding inside the car can both be correct about when the flashes happen. Their perspectives are equally real, even if they disagree about which lamp lit up first. This is the relativity of simultaneity, a phrase that sounds intimidating but simply means that the ordering of events depends on how you're moving. This idea was so radical that even scientists had trouble accepting it. After all, we don't feel time bending or tilting in our daily lives. At the speeds we move, walking, driving, riding trains, these effects are too small to notice. But as objects approach the speed of light, time and space start to behave in strange and beautiful ways. Special relativity showed that time is not a universal river. Instead, it flows differently for everyone, shaped by motion and perspective. If you could travel near light speed, your seconds would lengthen compared to those of someone staying behind. Your clock would slow down. Your heartbeat would stretch out. To you, everything would feel normal, but to your friends back home, you'd appear to be moving in slow motion. Einstein's insights didn't come from laboratory experiments alone. They were born from thought, imaginative journeys into what might happen if you chased a beam of light, or try to measure a moment in motion. Tonight, as you lie here in the quiet, you don't have to solve the equations to appreciate how extraordinary this is. The simple act of moving, the quiet glide of a train through the darkness, can reshape time itself. And while your life will likely never bring you to the edge of light speed, the truth remains. There is no single, absolute now. Just a tapestry of moments, each woven differently depending on where you stand and how you're moving through the universe. Imagine 2 twins standing side by side. For years they have shared the same moments, birthday candles, childhood games, long conversations that stretched into the small hours. But one day, one twin boards a spacecraft, preparing for a journey that will take her far from Earth, travelling at speeds that approach the speed of the light. As her engines fire and the planet falls away behind her, something astonishing begins to happen. To her, time feels perfectly ordinary. She eats meals, counts days, reads books. Her heart beats in the same steady rhythm it always has. But back home, her twin's clock is ticking faster. Days slip by, then months, then years. This is time dilation, one of the most famous predictions of special relativity. When you move very quickly, especially close to the speed of light, your experience of time slows compared, unravelling all the stories it has woven. But there is a quiet beauty in it too. Entropy makes change possible. It allows energy to flow, fuels the stars, drives the processes that create life. Even your memories depend on entropy. Recording information in your brain requires energy and leaves traces of heat, tiny increases in disorder. Every thought is a small act of reshaping the universe. So tonight, as you lie here, you might notice the warmth of your body softening into the cool air of your room. It's a reminder that time has a direction, and that every moment is part of a long unfolding story, one where order gives way to complexity, and complexity gradually gives way to something softer and simpler. And in that quiet drift there is nothing to fear. It's just the gentle arrow of time pointing onward, as it always has. Look up at the night sky, and you're seeing light that began its journey long before you were born. Some of those photons started travelling across space when woolly mammoths still wandered the Earth. Others are older still, messages from galaxies whose stars ignited before our planet had formed. This deep past lives in every point of starlight, and it hints at another arrow of time, one that stretches beyond any single life, beyond even the span of human history. It's called the Cosmological arrow of time, and it comes from the way the universe itself changes. From everything we can measure, the universe is expanding. Galaxies are drifting away from one another, space itself stretching like dough rising in a warm kitchen. If you imagine running time backward, the universe would contract, drawing all the matter and energy back to a single point, a moment we call the Big Bang. This expansion creates a clear direction in time. Earlier, the universe was smaller, hotter, and simpler. Over billions of years, it has grown larger and cooler, filled with increasingly complex structures, galaxies, stars, planets, and eventually, us. One of the ways scientists study this arrow is by observing the cosmic microwave background, the faint glow left over from when the universe was just 380,000 years old. Back then, matter and light were so tightly woven that the cosmos was opaque, like a fog. As it expanded and cooled, atoms formed, and the first light broke free, travelling across space to meet our telescopes. This ancient light is a kind of time capsule, a picture of a simpler universe. It tells us that time has a direction, because conditions were different in the past. Over time, order gives way to complexity, and complexity gradually relaxes toward equilibrium. The cosmological arrow and the thermodynamic arrow are linked in ways scientists are still trying to fully understand. One idea is that the early universe's low entropy, its smooth uniform state, set the stage for entropy to grow as matter clumped into galaxies and stars. In this view, the universe began with a kind of simplicity that made all later change, the same moment agreeing to meet in exactly 1 hour. But hidden in this peaceful scene is a subtle difference neither of you can feel, because you're standing higher up, a little farther from the pull of Earth's gravity. Your clock is ticking ever so slightly faster than your friends. This is gravitational time dilation, another remarkable consequence of Einstein's theories. While special relativity showed how motion can stretch or compress time, general relativity revealed that gravity does it too. The stronger the gravitational field you sit inside, the slower time moves for you compared to someone farther away. It sounds like science fiction, but it's a fact of our universe, confirmed by decades of experiments and observations. One of the most beautiful ways to picture this comes from imagining gravity not as a force, but as a curve. In Einstein's view, massive objects like Earth or the Sun bend the very fabric of space-time around them. When you place a ball on a rubber sheet, it makes a dip that pulls smaller objects toward it. In the same way, gravity creates a well in space-time, and time itself slows as you move deeper inside. Though the effect on Earth is tiny, a fraction of a second over many years, it becomes dramatic near extreme masses. If you could drift near the event horizon of a black hole, time would slow to a crawl. To an observer watching from a safe distance, it would look as if you were frozen at the edge, never quite crossing over. This is not just a theoretical curiosity. Even here on Earth, gravitational time dilation must be accounted for in the satellites that make GPS possible. Those high orbit clocks are farther from Earth's centre of gravity, so they run faster than clocks on the ground. Without correcting for both their speed, which slows their time, and their altitude, which speeds it up, GPS would drift by kilometres each day. Experiments have also confirmed gravitational time dilation in more direct ways. In the 1970s, physicists placed super-precise atomic clocks at the tops and bottoms of tall towers. Over time, the clocks ticked out of sync, showing that the higher clock really was moving ahead. And yet, for all its strangeness, this bending of time is part of the quiet architecture of reality. Every second you live passes inside the gentle curve of Earth's gravity. Your heartbeat, your breathing, your memories, they're all shaped, imperceptibly, by the mass beneath your feet. Sometimes, in stories, gravity is portrayed as something harsh or oppressive. But in truth, it's also a kind of shelter. It holds the atmosphere close, warms the ground, and guides the tides. And it carries time along with it, folding seconds and minutes into the soft contours of space-time. So tonight, as you rest, know that you are lying in a small, comforting valley in the universe's geometry. A place where time is a little slower than in the emptiness between the stars, where gravity's quiet embrace keeps you tethered to the Earth and keeps your clock gently, reliably ticking. If you've ever tried to plan your week on a calendar, you've already used a kind of map of time. You draw a little square around each appointment, each birthday, each moment you want to remember. In physics, scientists use a similar kind of map, but theirs stretches far beyond hours and days. This is the space-time diagram, a way to picture how time and space weave together into a single fabric. Imagine a simple graph. The vertical axis is time, steadily climbing upward, and the horizontal axis is space, stretching out to the left and right. Every object, from a drifting feather to a speeding comet, traces a line on this diagram. That line is called a world line, a record of the object's journey through time and space. If you sit perfectly still, let's say curled up under your blanket listening to this story, your world line goes straight up. You're not moving in space, but you're always moving forward in time. If you get up and walk across the room, your world line tilts slightly, showing that you're travelling through space as well as time. In this picture, light itself has a special path. Because it moves at the fastest possible speed, its world line tilts at exactly 45 degrees, halfway between space and time. No matter how fast you move, you can never tilt your path enough to outrun this diagonal. That's why nothing can go faster than light. It's not just a speed limit, it's a limit built into the geometry of space-time. One of the most powerful things about space-time diagrams is that they help us see why different observers might disagree about simultaneity. Remember the train and the platform? On the diagram, each observer slices time differently, like cutting a layered cake at a different angle. What seems now to one person is tilted relative to now for someone moving past. This is more than an abstract idea. It means that the notion of a universal present, a single moment shared by all things everywhere, is an illusion. Each observer carries their own version of the present, shaped by motion and position. Space-time diagrams can also show us events that can never influence each other. Imagine a point on the diagram representing you sitting here tonight. From that point, you could trace a cone spreading upward, the future light cone, containing all the events you could ever reach or affect, even if you sent signals at the speed of light. Likewise, there's a past light cone collecting every event that could possibly have influenced you. Everything outside these cones is elsewhere, so far away in space or time that no signal could ever connect you. This structure defines causality, the web of what can touch what and when. Even if you never draw one of these diagrams, the idea behind them is quietly beautiful. They remind us that every moment is embedded in a larger structure, that your place in the universe is defined not just by where you are, but by how you are moving through time. Tonight, your world line is calm and steady, a gentle vertical line in the fabric of space-time, a trace of your presence in this one small corner of the cosmos, and somewhere, countless other world lines are weaving past and through yours, composing a tapestry so vast and complex that no single perspective can ever see it all. And perhaps that's part of the wonder, to know that time is not simply ticking forward, but unfolding in a rich, multi-dimensional pattern. A pattern you are part of whether you notice it or not. If you've ever tidied a room, folding blankets, stacking books, sweeping crumbs into the bin, you know how quickly it can all unravel. By the next day, the cushions are slumped, the cups have multiplied, and the careful order you created has slipped back into gentle disorder. This small domestic truth reflects a grand principle that guides the entire universe, the tendency of systems to move from order to disorder. Scientists call it entropy, and it sits at the heart of the second law of thermodynamics. Entropy is a way to measure how many possible arrangements a system can have. A neatly stacked pile of playing cards has low entropy, only a few ways to be that tidy. But when you shuffle them, the number of possible configurations explodes. Disorder grows, and so does entropy. This is why time feels like it moves forward. It's why you can scramble an egg but never unscramble it. Why you can watch cream swirl into coffee but never swirl itself back out. Entropy increases. In a way, this thermodynamic arrow of time is the closest thing we have to an absolute direction. Many physical laws work the same whether time runs forward or backward. If you watch a video of planets orbiting a star, you can play it in reverse, and it still makes sense. But entropy doesn't cooperate. You can't unmix the cream. You can't uncrack the egg. Even the warmth of your body in this moment, your hands gently cooling against the night air, follows this rule. Heat spreads from warmer places to cooler ones. Energy disperses. Entropy grows. One of the most powerful ways to picture this is to think of the universe as a vast collection of particles, all jostling and shifting. At the beginning, right after the Big Bang, everything was hot and dense, low entropy in a sense, because it was so uniform. Over billions of years, matter clumped into stars and galaxies, and the universe expanded, making space for more possibilities, more arrangements, more entropy. This increase in entropy doesn't mean everything is doomed to chaos overnight. Local pockets of order still appear, like your tidy bookshelf or the carefully folded proteins in your cells. But they require energy to maintain. You have to do work to keep things orderly. The moment you stop, the natural drift toward disorder resumes. Sometimes, people find this idea a little melancholic, as though the universe were gently unravelling all the stories it has woven. But there is a quiet beauty in it too. Entropy makes change possible. It allows energy to flow, fuels the stars, drives the processes that create life. Even your memories depend on entropy. Recording information in your brain requires energy and leaves traces of heat. Tiny increases in disorder. Every thought is a small act of reshaping the universe. So tonight, as you lie here, you might notice the warmth of your body softening into the cool air of your room. It's a reminder that time has a direction, and that every moment is part of a long unfolding story. One where order gives way to complexity, and complexity gradually gives way to something softer and simpler. And in that quiet drift there is nothing to fear. It's just the gentle arrow of time pointing onward, as it always has. Look up at the night sky, and you're seeing light that began its journey long before you were born. Some of those photons started travelling across space when woolly mammoths still wandered the Earth. Others are older still, messages from galaxies whose stars ignited before our planet had formed. This deep past lives in every point of starlight, and it hints at another arrow of time, one that stretches beyond any single life, beyond even the span of human history. It's called the cosmological arrow of time, and it comes from the way the universe itself changes. From everything we can measure, the universe is expanding. Galaxies are drifting away from one another, space itself stretching like dough rising in a warm kitchen. If you imagine running time backward, the universe would contract, drawing all the matter and energy back to a single point, a moment we call the Big Bang. This expansion creates a clear direction in time. Earlier, the universe was smaller, hotter, and simpler. Over billions of years, it has grown larger and cooler, filled with increasingly complex structures, galaxies, stars, planets, and eventually, us. One of the ways scientists study this arrow is by observing the cosmic microwave background, the faint glow left over from when the universe was just 380,000 years old. Back then, matter and light were so tightly woven that the cosmos was opaque, like a fog. As it expanded and cooled, atoms formed, and the first light broke free, travelling across space to meet our telescopes. This ancient light is a kind of time capsule, a picture of a simpler universe. It tells us that time has a direction, because conditions were different in the past. Over time, order gives way to complexity, and complexity gradually relaxes toward equilibrium. The cosmological arrow and the thermodynamic arrow are linked in ways scientists are still trying to fully understand. One idea is that the early universe's low entropy, its smooth uniform state, set the stage for entropy to grow as matter clumped into galaxies and stars. In this view, the universe began with a kind of simplicity that made all later change possible. And yet, for all its vastness, the cosmological arrow is something you can feel in small human ways. You feel it in the passage of seasons, the slow drift of constellations across the night sky, the way winter gives way to spring, the way everything changes in rhythms much older than any one life. When you look up at the stars tonight, you're seeing a record of expansion. The light you catch in your eyes has been stretched by the growth of space itself, softened into longer wavelengths, its colour shifted toward the red. Every twinkle overhead is a whisper from a younger universe, carried across time by the quiet unfolding of cosmic history. And as you breathe here, your heart beating at its own steady pace, you're part of that same story, a small, warm creature in an ancient, ever-expanding cosmos. Your moments are measured by the slow bloom of galaxies, the soft drift of light, the ceaseless widening of the sky. Perhaps that's why the night feels so peaceful. It reminds you that time is both personal and immense, that while your days and years come and go, you're also carried forward on a current that began billions of years ago and will continue long after you're gone. Tonight, you can simply rest in that knowledge. You don't have to hold it all in your mind. Just know that the arrow of time runs through everything, and that you are exactly where you belong in its unfolding. Close your eyes for a moment and think of a memory you cherish, something simple, like a quiet morning or a favourite walk. Notice how it sits behind you, tucked neatly in the past, impossible to reach again except by recollection. This experience is so ordinary that it rarely feels strange, but it holds a remarkable truth. While many physical laws don't care about the direction of time, your mind does. You can remember yesterday, but you cannot remember tomorrow. You can plan, imagine, and hope, but you cannot recall the future. This is the psychological arrow of time, the way your consciousness insists on moving forward moment by moment. It is intimately tied to memory. Your brain builds a record of what has already happened, and it uses that record to make predictions about what might come next. In this sense, memory isn't just a storage system, it's a guide, a way to navigate the world by comparing the present with what you've known before. Without it, every moment would be disconnected from the last, and the flow of time would feel chaotic, unanchored. Scientists have studied how this forward motion is mirrored in biology. Your body too has clocks that count out your days in a single direction. Cells divide and grow old. DNA accumulates small changes over time. Tissues repair themselves, but never quite perfectly. All these tiny processes add up to the experience we call aging, biological arrow that runs in lockstep with time's other directions. Even your circadian rhythm, the daily cycle of wakefulness and rest, depends on moving forward through a sequence of signals and hormones. The hormone melatonin, for example, rises in the evening to prepare you for sleep, then falls away with the morning light. No matter how hard you try, you can't persuade your body to reset itself backward. Sometimes we notice this arrow most clearly when it stutters or goes awry. For people with certain kinds of brain injury or dementia, the ability to form new memories is disrupted. They live in an eternal present, able to recall long ago events, but unable to record what is happening now. For them, time feels strangely fragmented, proof that memory is the thread tying the past to the present. You also see this asymmetry in how we experience cause and effect. If you drop a glass, it shatters, never the other way around. If you light a candle, it burns down to wax and smoke. Your brain expects this sequence, and when it is reversed, even in a film, it feels uncanny, as if the rules of the world have been violated. There is something quietly reassuring in knowing that this forward flow is universal among humans. Every culture, every language has ways of describing it, before and after, old and young, memory and anticipation. We build our stories on it, mark our milestones with it, and use it to measure the span of a life. And tonight, as you rest here, your own mind continues its patient recording. Even as your thoughts soften and begin to drift, the moments are being quietly stored. Little impressions you may recall tomorrow, or perhaps never again. You don't have to do anything to make this arrow move. It is part of you, woven into your cells, etched into your memories, carried along by the same laws that guide the stars. And perhaps, in this gentle inevitability, there is a kind of comfort. Time goes forward. So do you. Together you cross each moment only once, and then you let it go. If the universe sometimes seems tidy and predictable, like a well-organized clock, quantum mechanics is the place where that neatness dissolves. Here, at the smallest scales imaginable, particles flicker in and out of certainty, and time becomes something stranger than most of us can comfortably picture. In the everyday world, you can count on cause and effect. You flip a switch, and the light turns on. You drop your keys, and they fall to the floor. But in quantum physics, outcomes are described by probabilities rather than certainties. A particle doesn't simply have a position or a speed. It has a range of possible values, all superimposed until the moment you measure it. This uncertainty spills over into how we think about time. Some interpretations of quantum mechanics suggest that, in a sense, all possible futures coexist in a shimmering cloud of potential, only collapsing into a single reality when observed. One of the most famous illustrations of this idea is the thought experiment known as Schrödinger's cat. Imagine a cat in a sealed box with a small amount of radioactive, the sun and moon to measure longer spans, planting seasons, festivals, the rhythm of years. But calendars were often imperfect, slipping out of alignment with the seasons. In 1582, Pope Gregory XIII introduced the Gregorian calendar, correcting the drift that had accumulated in the old Julian system. This adjustment, dropping 10 days and redefining leap years, brought the calendar back in step with the equinoxes. Though it took centuries for every country to adopt it, the Gregorian calendar remains the standard used by most of the world today. With these advances, time grew more precise and less local. It became possible to coordinate activities over great distances, to say, with confidence, when a ship would depart or when the new year would begin. And yet, for all this progress, timekeeping remained a blend of science and symbolism. In many towns, the striking of a bell still carried a sense of ceremony. The slow tolling of midnight or the jubilant chime at noon was a reminder that time was not only measured but shared. Tonight, as you sit quietly, you might imagine the slow swing of a pendulum inside a wooden case, marking the seconds with patient regularity. Or the click of gears turning in the darkness of a bell tower, hidden behind stone walls that have watched centuries drift by. Mechanical clocks did more than divide the day into hours. They changed how people thought about life itself, introducing schedules, deadlines, and the idea that time could be owned and spent. And though we now carry tiny digital clocks in our pockets, each precise to the second, the quiet dignity of these old mechanisms still endures. A reminder that measuring time is as much about feeling connected to each other as it is about counting the minutes. If mechanical clocks brought order to human life, atomic clocks brought precision to the entire planet. Imagine holding a watch so accurate that it would not gain or lose even a single second over millions of years. This is not science fiction. It is the quiet triumph of measuring time by the vibrations of atoms. Before atomic clocks, the definition of a second was tied to the motion of the Earth. For centuries, a second was calculated as 1/86,400th of a day, the time it took our planet to spin once on its axis. But as scientists refined their instruments, they discovered that the Earth does not keep perfect time. Its rotation wobbles and slows, nudged by tides, tectonic shifts, and even weather. To find something more reliable, researchers turn to the heart of matter itself. Atoms have natural frequencies, tiny, precise vibrations that can serve as reference points. The most famous of these is the cesium-133 atom, which oscillates at an astonishingly regular rate. In 1967, the International System of Units redefined the second as the duration of 9,192,631,770 cycles of the radiation associated with the transition between two energy levels of cesium-133. If that sounds abstract, you can picture it this. Intuition is part of why the arrow of time feels so natural. In daily life, causes precede effects. Ice melts in your glass, the sun rises and sets, you grow older. Each moment seems to carry the memory of the last, while the future remains unwritten. And yet, when you look at the fundamental laws that describe the world, especially the equations of motion, they don't care about this forward flow. The mathematics that govern particles and forces work just as well in reverse. This property is called time symmetry, and it means that, in theory, the universe could run backward without breaking its own rules. This idea is easier to grasp with simple systems. If you imagine two billiard balls colliding on a frictionless table, you can reverse their velocities and they will retrace their paths exactly. Nothing in the equations requires a preferred direction. So where then does the arrow of time come from? Why does life feel irreversible when the rules are neutral? The answer lies in entropy. While microscopic processes don't require time to flow forward, large systems, like your cup of coffee cooling or your heart beating, are made of trillions of particles whose collective behaviour overwhelmingly moves toward disorder. It is vanishingly unlikely for the warmth in your coffee to spontaneously gather itself up again. In this way, the increase of entropy acts like a guidepost, giving time the appearance of direction. From low entropy beginnings, the universe evolves toward higher entropy states. This statistical trend is so consistent that it becomes, in practice, the foundation of memory, causality, and experience. Some physicists have proposed that the ultimate symmetry of time could mean our experience is only a matter of perspective, that the past and future are equally real, simply viewed from opposite ends. This idea is often called the block universe or Eternalism. In this view, time isn't flowing like a river. Instead, it's more like a vast landscape, with all moments, past, present, future, existing together. But even if the universe is time-symmetric at its core, your life is a story that unfolds in one direction. You remember what has happened, not what will happen. You wake up each morning in a body that has aged one day more. You walk forward through each moment, never backward. Perhaps there is a quiet wisdom in this asymmetry. If time were perfectly reversible, if everything played forward and backward without difference, there would be no novelty, no anticipation, no change. The arrow of time gives life its poignancy, its sweetness and its urgency. Tonight, as you rest, your body continues its small, irreversible journeys. Warmth drifting into the air, breaths exchanged with the darkness around you, thoughts and memories quietly settling into place. And though the equations of physics might not care which way time runs, you can be grateful that, in this moment, time is carrying you gently onward, step by step, into the next small chapter of your story. Picture, if you will, a long shelf lined with the books. Each volume tells a single chapter of your life, your first steps, your first day of school, the taste of summer strawberries, the sound of rain on the roof as you drifted to sleep. In the block universe, every one of those moments still exists. None of them vanish when you turn the page. Instead, they're all quietly arranged side by side in a four-dimensional structure that contains every event that has ever happened, or ever will. This idea comes from the way Einstein's theory of relativity reshaped our understanding of time. Once we discovered that simultaneity depends on where you stand and how you move, the notion of a single universal now began to dissolve. Instead of thinking of time as flowing past you like a river, some physicists began to picture it as a landscape, a block of space-time that simply is. In this block universe, past, present and future are equally real. You, sitting here tonight, are just as real as the you who will wake up tomorrow, or the you who first learned to read. From this perspective, time doesn't flow. All moments are laid out together, and consciousness simply experiences them one by one. This picture can feel unsettling. After all, we're used to thinking of the past as gone and the future as open. But in the block universe, your birth and your final day both exist as part of a single, unchanging whole. Yet there is a kind of peace in this too. If every moment is real, nothing is ever truly lost. The warmth of a childhood embrace, the laughter of an old friend, the smallest kindness you've given or received, all of it remains fixed in space-time, like a star whose light will never fade. Some philosophers call this view Eternalism, the belief that all points in time are equally real, and that the sense of time flowing is a feature of perception rather than the universe itself. Of course, this is not the only way to see things. Other schools of thought argue that the present moment is the only true reality, that the past is no more than a memory, and the future only a possibility. But even those who disagree with the block universe find it hard to deny that relativity has forced us to reconsider what we mean by now. When you look at the equations that describe space-time, there is no special marker saying, this slice is the present. The laws work just as well for any cross-section. It is only in your mind, in the unfolding of thoughts and sensations, that the feeling of this moment as uniquely real arises. Tonight, you don't have to choose which interpretation feels truer. It's enough to imagine that time might be bigger than it seems, that each moment you have loved is still quietly there, tucked into the vast library of space-time waiting for someone or something to turn the page again. And if you find comfort in that image, you can carry it with you. A reminder that you are not merely travelling through time, but that you're part of something broader and deeper, a tapestry where every instant has its place, and where nothing precious ever entirely disappears. If the block universe is like a library where every moment has already been written and shelved, Presentism is more like a candle flame, burning only here, in the slender gap between past and future. According to Presentism, the past no longer exists, the future has not yet come to be, only the present is real. In this view, Time is a kind of unfolding, each moment flickering into existence, then immediately giving way to the next. Many people find this idea more intuitive. After all, it matches how we feel day to day. When you think back to last year, you don't sense that the past is still out there. It feels like a memory, an echo, but not something still happening somewhere beyond your sight. Presentism has deep philosophical roots. Thinkers since Aristotle have argued that the present must be special, because it is the only place where experience actually occurs. The past is a record, the future is a possibility. But the now is where life is lived. Yet physics complicates this picture. Relativity tells us there is no single present shared across the universe. What is happening now for you might be in someone else's past or future. Two observers moving differently will disagree about which events are simultaneous. Imagine two friends floating in space, travelling in opposite directions at near the speed of light. Each has their own version of what is happening right this instant. If presentism is true, whose present counts as real? Some philosophers have tried to reconcile this problem by suggesting that now is always local, a small bubble around you, defined by your motion and position. But even so, relativity shows that time's boundaries are softer than we once believed. Eternalism, by contrast, suggests that all moments exist equally. The past is as real as the present, and the future is already woven into the fabric of space-time. In this view, our sense of flowing time is a feature of consciousness moving across the block, like a beam of light sweeping over a landscape. It can be unsettling to think the future might already exist, waiting to be experienced. But it also offers a kind of solace. If all moments are equally real, then nothing is ever truly lost. Every joy and sorrow remains, held in the structure of space-time like beads, strung along an endless thread. Neither presentism nor eternalism has been universally accepted. The question of which picture is true, or whether either captures the full story, remains open. Some physicists and philosophers believe we still lack the language, or the evidence, to describe time as it truly is. Perhaps that's fitting. Time is not only the medium in which we live, it is also the thing we are trying, with our small and curious minds, to understand from the inside. Tonight, you don't have to decide which philosophy to trust. You can simply hold them both as possibilities. Perhaps time is a candle, each moment burning bright and then vanishing. Or perhaps it is a vast landscape, where every path you have ever walked still lies beneath the same patient stars. And either way, you are here, alive in this particular breath, this particular second. The present may be fleeting, or it may be part of something eternal, but for now it is yours to inhabit fully. Imagine holding a snowflake in your palm. Its delicate shape feels inevitable, as though it could never have formed any other way. Yet its intricate pattern emerges from countless tiny collisions of water molecules, each following simple rules. Some physicists believe time itself might be like that snowflake. Not fundamental, but an emergent property arising from deeper, simpler processes we have not yet fully understood. In this view, time is not woven into the fabric of reality at the smaller scales. Instead, it emerges only when many particles and forces combine into something that feels continuous and directional. One clue pointing to this possibility comes from the strange world of quantum gravity, where the familiar rules of space and time start to blur. Theories like loop quantum gravity suggest that space itself is made of discrete granular units, tiny loops or quanta that, when viewed up close, don't look anything like the smooth dimensions we know. If space can be emergent, some researchers wonder, why not time? In certain equations describing the quantum universe, time disappears altogether. The famous Wheeler-DeWitt equation, for example, tries to combine quantum mechanics with general relativity. Strangely, it has no term for time. It describes a timeless universe. a landscape containing every possible configuration of reality, all at once. So where does the feeling of time come from? One idea is that time arises from entanglement, the invisible connections between quantum systems. As these connections spread and grow more complex, they create an appearance of change, of before and after, of moments following each other in a smooth procession. Imagine an orchestra warming up. Each instrument plays notes in isolation, without rhythm or melody. But when the conductor lifts a hand, the fragments align into something coherent. Time, in this analogy, is the music, emerging only when the parts move in relationship to each other. Some physicists think this perspective could eventually help solve the puzzle of reconciling quantum mechanics and gravity. If time is not fundamental, but emergent, it might explain why we cannot yet find a single theory that describes the universe at all scales. Of course, these ideas remain speculative. We have not yet measured the granularity of space-time or proved that time arises purely from entanglement, but even unproven, they invite us to imagine something deeper, that our experience of flowing time is a story built from countless smaller interactions, woven together so finely that it feels smooth and inevitable. And perhaps that is the gift of curiosity, not to settle every question, but to keep wondering, to keep listening for the music that might be hidden beneath what seems silent. Tonight, as you lie here in the quiet, time feels real and solid. You can feel its gentle pull as your thoughts slow and your breathing steadies. Whether it is a fundamental dimension or an emergent melody, it cradles you all the same, carrying you from this moment into the next. And whatever secrets time keeps, you don't need to unlock them to be part of its unfolding. Simply being here, breathing, wondering, resting is enough. Close your eyes for a moment and pay attention to the feeling of this instant. Not the memory of a second ago, or the expectation of the next moment, but simply the small luminous point of now. It's harder to hold on to than you might expect. The present slips away as soon as you notice it, replaced by the next flicker of awareness. Some philosophers call this the specious present, the brief window of time your mind gathers into what feels like a single unified moment. For most people, this window is only a few seconds wide. You can think of it as the duration of a passing thought, or the span of a musical phrase. If it were shorter, your experience would feel fractured, like watching a film chopped into single frames. If it were longer, you'd lose the sense of change and causality. Consciousness itself seems to be stitched together from these small pieces of time. Your brain collects sensations, thoughts, and emotions, and binds them into a continuous story. Without this integration, life would feel like a series of disconnected impressions. Neuroscientists have found that your perception of time is spread across many parts of the brain. Different networks handle different scales of timing, milliseconds for recognizing sounds, seconds for understanding speech, minutes and hours for memory and planning. This mosaic of timescales is part of why time feels so fluid. A minute spent waiting can feel much longer than a minute spent listening to music. The brain's internal clocks are always adjusting, speeding up or slowing down depending on attention, emotion, and expectation. There is also evidence that the brain actively predicts the near future. Every moment you perceive is shaped not just by what has happened, but by what you expect to happen next. Your mind is always a little ahead of itself, leaning forward into the next moment. This constant anticipation helps you navigate the world smoothly. When you catch a ball, you're relying on predictions your brain has made fractions of a second in advance. When you listen to speech, your brain guesses the next syllable before it arrives. It's humbling to realise that even your sense of now is partly constructed, a composite of immediate input, short-term memory, and expectation. In this sense, consciousness is not a perfect clock, but more like a painter, layering impressions until the image feels whole. Some researchers have wondered whether time itself is inseparable from consciousness. If no observer were present to experience the passage of time, would it still feel like a flow? Or would it be simply a static landscape of events, waiting in silence? These questions can feel abstract or even unsettling, but they also remind us that time is more than a measure of duration. It is the canvas on which your life unfolds and the thread that ties each thought to the next. And perhaps, in those moments when you feel most present, sitting quietly in the dark, listening to your breath, you glimpse the softness of time, the way it emerges not only from physics but also from awareness. Tonight, you don't need to solve the mystery of time and consciousness. You can simply rest in the wonder that you are here, awake to this moment, woven into the slow, invisible current of time. This moment will pass, another will arrive, and your mind, with its patient curiosity, will keep stitching them together into the story only you can tell. Imagine, for a moment, a universe far older than the one you know. Stars have burned through their fuel, their light winking out one by one. Galaxies have drifted so far apart that their glow no longer reaches their neighbours. Even the black holes, those quiet engines of gravity, have evaporated into faint whispers of radiation. This is one vision of the distant future, sometimes called the heat death of the universe. In this scenario, entropy has reached its maximum. There is no remaining difference in temperature, no gradients to drive movement or change. Everything is still, cold, thin and quiet. In such a universe, time itself begins to lose meaning. Without change, there is nothing to mark one moment from another. No processes to tick forward, no clocks to count the seconds. It is a place where time may still exist in principle, but has no practical measure. This idea can feel melancholy, like imagining the last note of a long song fading into silence. But some scientists see a strange beauty in it, a final equilibrium, a perfect balance where nothing is wasted and nothing is left undone. There are other speculations too. Some cosmologists imagine that the universe might eventually collapse in a big crunch, reversing its expansion and drawing all matter back into a single, dense point. In that scenario, time might feel as though it is running backward, entropy decreasing as everything grows hotter and more uniform. Other theories propose that our universe is only one bubble in a vast multiverse, where new universes are constantly budding off, each with its own flow of time and its own fate. And still others wonder whether time itself is an emergent property that could one day evaporate, leaving behind a timeless state where the distinction between before and after disappears. These ideas are speculative, thought experiments more than certainties. But they remind us that time, like everything else, has a history and perhaps even a lifespan. You don't have to look billions of years ahead to feel the poignancy of this. Even in our small corner of the cosmos, time shows its transience. The flowers that bloom and wither in a single season, the waves that rise and fall leaving only foam behind, the faces you love, changing gently with each passing year. Some traditions teach that impermanence is not something to grieve, but something to cherish. Because everything changes, each moment is unique, never to be repeated, never to be reclaimed. Tonight, as you listen to this quiet reflection, you are part of that vast unfolding. You're here, in a small and fleeting present, surrounded by change. And whether time ends in a cosmic hush, or flows on forever in new and unexpected forms, you have this moment, this breath, this heartbeat, to inhabit fully. You don't have to solve the riddle of time's ultimate fate. It is enough to know that you are woven into its story, and that your own small span of years is precious, precisely because it cannot last forever. So take a slow, steady breath. Feel the quiet of the room around you, and know that whatever the universe becomes, you have been part of its brief, shimmering bloom of awareness. Before clocks or calendars, before any notion of minutes or seconds, our ancestors learned to measure time by watching the light. Imagine a small settlement thousands of years ago. At dawn, the sun climbs slowly over the horizon, warming the stones and signalling that the day's work can begin. Shadows shorten and lengthen in a silent rhythm no one needs to explain. Time is felt in the turning of the earth, the changing of the seasons, the slow sweep of stars across the night sky. The first timekeepers were the simplest of all, sundials, just a stick planted upright in the ground. As the sun moved, the shadow crept along in a predictable arc. By marking its path with stones or lines scratched into the dirt, people could divide the day into intervals. A sundial told you not just what hour it was, but something more intimate. How much daylight remained to finish your tasks, when to prepare for nightfall, when to gather with others around the fire. Other early tools for measuring time relied on more constant flows. Sand trickling through a narrow neck of glass, water dripping from one vessel into another. These were the ancestors of the hourglass and the clepsydra, or water clock. A water clock could measure time even after the sun had set. In ancient Egypt, priests used them to track the hours of the night, ringing bells or calling out prayers as each interval passed. In Greece, clepsydras were placed in law courts to limit the length of speeches. When the water ran out, the speaker's time was over. These methods were simple, but they carried a quiet elegance. A water clock did not need gears or springs, only gravity and patience. An hourglass required no power, only the slow, steady fall of grains too small to count. For centuries, time was measured locally and practically. A sundial worked best in your own courtyard, calibrated to the latitude where you lived. Noon in one village might come a few minutes before or after noon in the next. It wasn't until people began to travel and trade over long distances that they needed to agree on something more precise. Yet even now, there is something comforting about these earliest ways of keeping time. They remind us that time is not only an abstract number but a lived experience, woven into light and shadow, the drip of water, the soft hush of sand. Tonight as you rest, you can imagine the quiet regularity of an ancient water clock marking out the hours, each drop a small, patient measure of existence, each interval a reminder that even in the darkness, time flows onward. And perhaps in a world filled with digital displays and atomic precision, there is still a place for these simple, tactile rhythms, a reminder that timekeeping began with nothing more than careful attention and the desire to understand the days as they passed. Imagine walking through a medieval town at dawn. The streets are hushed, the stones still holding the chill of the night. High above, in the bell tower, a great weight begins to fall, turning gears that move a hand across a dial. And then, clear and resonant, the bell tolls, calling everyone to wake, to pray, to begin their day. This was the promise of mechanical clocks, to bring time down from the sky and give it a voice. No longer measured only by shadows or water, time could now be divided into hours and minutes that belonged to everyone at once. The first mechanical clocks appeared in Europe around the 13th century. They were grand, heavy machines, massive gears, iron weights, ropes winding around spindles. At their heart was an invention called the escapement, a clever mechanism that released stored energy in a controlled rhythm. With each swing of a pendulum or balance wheel, the escapement advanced the gear by a precise increment, making it possible to count time evenly. These early clocks had no faces. They announced the hours with bells, because most people could not read and had no personal timepieces. Time was something communal, something you heard together in the marketplace, the church, or the town square. As mechanical clocks grew more sophisticated, they became symbols of civic pride. In many cities, clock towers were adorned with intricate dials, painted moons and stars, moving figures that mark the passage of hours with tiny performances. Timekeeping also became important for navigation and trade. Sailors needed accurate measurements to chart their course across the seas. Merchants needed reliable schedules to coordinate markets and deliveries. Alongside clocks, societies refined their calendars. different cultures had long used cycles of the sun and moon to measure longer spans, planting seasons, festivals, the rhythm of years. But calendars were often imperfect, slipping out of alignment with the seasons. In 1582, Pope Gregory XIII introduced the Gregorian calendar, correcting the drift that had accumulated in the old Julian system. This adjustment, dropping 10 days and redefining leap years, brought the calendar back in step with the equinoxes. Though it took centuries for every country to adopt it, the Gregorian calendar remains the standard used by most of the world today. With these advances, time grew more precise and less local. It became possible to coordinate activities over great distances, to say, with confidence, when a ship would depart or when the new year would begin. And yet, for all this progress, timekeeping remained a blend of science and symbolism. In many towns, the striking of a bell still carried a sense of ceremony. The slow tolling of midnight or the jubilant chime at noon was a reminder that time was not only measured but shared. Tonight, as you sit quietly, you might imagine the slow swing of a pendulum inside a wooden case, marking the seconds with patient regularity. Or the click of gears turning in the darkness of a bell tower, hidden behind stone walls that have watched centuries drift by. Mechanical clocks did more than divide the day into hours. They changed how people thought about life itself, introducing schedules, deadlines, and the idea that time could be owned and spent. And though we now carry tiny digital clocks in our pockets, each precise to the second, the quiet dignity of these old mechanisms still endures. A reminder that measuring time is as much about feeling connected to each other as it is about counting the minutes. If mechanical clocks brought order to human life, atomic clocks brought precision to the entire planet. Imagine holding a watch so accurate that it would not gain or lose even a single second over millions of years. This is not science fiction. It is the quiet triumph of measuring time by the vibrations of atoms. Before atomic clocks, the definition of a second was tied to the motion of the Earth. For centuries, a second was calculated as 1/86,400th of a day, the time it took our planet to spin once on its axis. But as scientists refined their instruments, they discovered that the Earth does not keep perfect time. Its rotation wobbles and slows, nudged by tides, tectonic shifts, and even weather. To find something more reliable, researchers turn to the heart of matter itself. Atoms have natural frequencies, tiny, precise vibrations that can serve as reference points. The most famous of these is the cesium-133 atom, which oscillates at an astonishingly regular rate. In 1967, the International System of Units redefined the second as the duration of 9,192,631,770 cycles of the radiation associated with the transition between two energy levels of cesium-133. If that sounds abstract, you can picture it this way. Inside every cesium atom is a tiny clockwork of energy states. As the atom shifts from one state to another, it emits radiation that ticks with a consistency no mechanical pendulum can match. An atomic clock uses this signal to regulate a quartz oscillator, producing time intervals of extraordinary precision. Modern cesium clocks are so stable that they would drift less than a second over hundreds of millions of years. These clocks do more than satisfy scientific curiosity. They are woven into the infrastructure of modern life. GPS satellites, for example, rely on atomic clocks to triangulate your position. The signals your phone receives are stamped with time codes, accurate to billionths of a second. Without this precision, your blue location dot would drift wildly across the map, making navigation impossible. Atomic clocks also serve as the backbone of Coordinated Universal Time, UTC, the time standard that governs everything from international flight schedules to stock market transactions. If you have ever wondered why your smartphone, your computer, and your kitchen oven all show the same time, it is because they are ultimately syncing to signals that trace back to atomic standards. And yet, for all their precision, atomic clocks are still subject to the relativistic effects you've learned about. Satellites orbiting high above Earth tick faster than clocks on the ground, due to weaker gravity but slower because of their high speeds. Every day, engineers apply small corrections to account for these shifts. A quiet reminder that even the most perfect clocks are woven into a universe where time is flexible. There is something humbling in this. At the core of our most advanced timekeeping lies a simple, elegant fact. The universe itself provides rhythms more reliable than any human invention. Tonight, as you sit here, your own heart keeps its beat with soft regularity. Your breathing marks out the minutes in a language older than any clock. And somewhere, far above, satellites orbit the Earth, carrying clocks that count out the seconds with a precision almost impossible to imagine. All of them, your pulse, the ticking of the quartz in your watch, the vibrations of cesium atoms, are different ways of reaching for the same thing, a way to measure the mysterious unfolding of time. And perhaps in this gentle convergence of heartbeats and atomic pulses, there is a small, comforting truth. No matter how precise our instruments become, time remains both universal and intimately personal. It's easy to think of relativity as something distant, an exotic property of black holes or spacecraft racing through interstellar darkness. But the truth is, relativity quietly shapes your daily life in ways you may never notice. Consider the phone in your hand. Every time you use a map to find a restaurant or track a parcel, you're relying on a constellation of satellites orbiting thousands of kilometers above the Earth. These satellites are equipped with atomic clocks that keep time accurate to billionths of a second. But here's the curious part. Those clocks don't tick at the same rate as the clocks on the ground. Because the satellites are moving rapidly, about 14,000 kilometers per hour, their clocks experience special relativistic time dilation, ticking slightly more slowly than yours. At the same time, because they are high above the Earth and feel a weaker pull of gravity, they experience gravitational time dilation, which makes their clocks tick slightly faster. These two effects don't cancel each other out perfectly. The net result is that, without correction, the satellite clocks would drift ahead by about 38 microseconds per day. That may sound tiny, but over time it would throw GPS calculations off by kilometers. Engineers anticipated this. Every satellite clock is calibrated to account for both kinds of time dilation. The adjustments are small but essential, a quiet testament to how profoundly Einstein's insights shape the world you live in. Even on Earth, relativity leaves its subtle fingerprints. If you placed an atomic clock at the top of a mountain and another at sea level, you would find that the clock higher up runs faster, accumulating nanoseconds of difference. In 2010, scientists at the US National Institute of Standards and Technology demonstrated this effect over a height difference of just 33 centimeters, the span from your feet to your knees. That's how sensitive time is to position and gravity. These effects are not limited to advanced laboratories. Commercial airliners, travelling at hundreds of miles per hour and flying miles above the surface, experience measurable time dilation too. On a long flight, your watch gains a few billionths of a second compared to someone waiting for you on the ground. This may feel abstract, far removed from the warmth of your room or the softness of your blanket. But it is a reminder that you are living in a universe where time is never absolute. Every heartbeat, every tick of your watch, every second that drifts past tonight is woven into a web of motion and gravity you can't see but can measure with astonishing precision. And perhaps there is something comforting in that. While your experience of time is personal, shaped by memory, feeling and attention, it is also part of a deeper fabric that unites you with satellites in orbit and distant galaxies alike. Tonight, as you lie still, you are moving too. The Earth spins beneath you, carrying you eastward at hundreds of meters per second. The planet orbits the sun. The sun drifts through the Milky Way. Each of these motions nudges the rate at which time passes for you, in ways too small to feel but large enough to matter. And so, when you check the time tomorrow, when you glance at your phone or your kitchen clock, you're seeing the sum of countless adjustments, corrections, and calibrations. A shared effort to keep time in step with a universe that refuses to tick at just one speed. In this quiet dance of motion and gravity, your moments are both unique and connected, threads in a tapestry so vast it humbles imagination. Tonight, you've travelled through many ways of thinking about time. You've watched it unfold in the measured drip of water clocks and the dance of atomic vibrations. You've seen it bend near black holes and stretch in the mind's quiet spaces. And perhaps, after all these ideas, time feels no simpler than when you began. That's all right. Time is not only a question to be answered, but a presence to be felt. In the hush of this moment, you can notice the simple fact of being here, now, a creature of memory and curiosity, cradled in a universe so vast that the seconds of your life are like tiny sparks, yet these sparks are precious. They light your days with meaning, moments when you laugh, when you learn, when you sit quietly with someone you love. Moments like this one, when you let yourself pause and wonder. It's humbling to think that the atoms in your body are older than the Earth itself, that your heartbeat is regulated by chemistry and electricity shaped by billions of years of evolution, that the time you measure with your watch has been refined by countless hands, from the first sundial to the latest satellite, and that behind every clock and calendar is the same quiet desire to make sense of the fleeting, to trace a pattern in what passes. No matter how precise our measurements become, time will always be a little slippery, a little more than we can hold in words, a little less than we can fully understand. But maybe that is its gift. If time were entirely knowable, it would lose some of its softness, some of its wonder. Tonight, you can let the questions rest. You can let the clocks tick without needing to count. You can feel the presence of time as something both intimate and infinite, woven into the rising and falling of your breath. Whether you think of time as a river, a landscape, or a flickering illusion, it remains the stage where your life unfolds, a place you can never leave and never quite grasp. And perhaps that is enough, to be here for a little while, to watch the moments drift past, and to know that you are part of something so much larger than yourself. Perhaps the most comforting truth about time is that you don't need to fully understand it to feel its kindness. Time is in the warmth of your hand as you hold a cup of tea, in the hush of dawn when the first light spills across the floor, in the way your thoughts slow when you finally allow yourself to rest. It's easy to think of time as an enemy, something that takes, something that limits. But time is also what allows everything to happen at all. Without it, there would be no music, no change, no growth, no gentle unfolding of moments into the shape of a life. You may never know whether time is a river carrying you forward or a landscape you walk through, moment by moment. You may never decide whether the future already exists or whether each new instant is born fresh and unrepeatable. But you don't have to decide tonight. Tonight, you can simply be here. You can feel the steady rhythm of your heart, the softness of the pillow beneath your head, the patient arrival of sleep at the edges of your mind. In the morning, time will start its measured counting again. You will feel the day begin. Perhaps you will remember this quiet hour, or perhaps it will slip away into the library of unremarkable nights. Either way, it will have done what time always does, carried you gently from where you were to where you are now. And maybe that is all any of us can ask for. To be carried forward with just enough grace to notice the sweetness in the passing, to appreciate that each moment is unique and irreplaceable. Time is not only measured in seconds and hours, it is also measured in the quiet spaces between thoughts, in the hush of a room after the lights are turned out, in the simple awareness of being alive. As you rest, know that nothing more is required of you. The clocks will keep time without your attention. The earth will turn, the stars will drift in their long, slow arcs across the darkness, and you can let go of the questions, the calculations, the need to hold on to every instant. Because right now, in this small, perfect moment, you have everything you need: time, breath, and the quiet knowledge that you are part of something vast and tender, something that began long before you were born and will continue long after you are gone. And perhaps, as you drift towards sleep, you can feel the gentleness of that truth, like a hand resting lightly on your shoulder, a reminder that you belong here, in this moment, and that time, whatever it is, has made a place for you. And so, we come to the end of this exploration, a gentle walk through the landscapes of time, from the steady drip of ancient water clocks to the mysterious rhythms of quantum uncertainty. You have wandered across centuries and theories. You have looked up at galaxies whose light began its journey before humans ever built a calendar. You have felt the tug of entropy, the softness of memory, and the deep question of what it means to exist in a universe that never stands still. And perhaps, as the hours have passed, you have noticed your own sense of time shifting. The minutes here have no urgency. There is no race to finish, no test to pass, no requirement to hold every idea perfectly in your mind. This has always been the quiet promise of curiosity, that it asks nothing more than your presence, a willingness to wonder, to let your thoughts drift without needing to land anywhere final. Time will keep unfolding whether you watch it or not. The seconds will keep stepping forward, soft as footprints in fresh snow. Somewhere, far above you, satellites continue their patient orbits, marking out the billionths of seconds that keep your world in sync. Somewhere, closer, your heart ticks out its own tempo. A quieter, more human clock that has been beating since before you ever learned to count. And beyond all of it, in a scale almost impossible to imagine, the universe keeps expanding, carrying every star and planet away from every other. The great clockwork of the cosmos, moving with a patience no watch could ever measure. Yet in this moment, none of that demands your attention. All that is asked of you now is to feel the softness of your breath, the weight of your body resting here, the hush that gathers when you allow yourself to stop striving. Time may be a river, or a landscape, or a fragile illusion. It may be something that began with the Big Bang, or something that emerges each time you open your eyes. Whatever it is the medium of your life, the canvas where your days and nights unfold, the gentle thread that ties each thought to the next. And here, in this small hour, you can simply be part of it. No explanation required. If your eyelids are heavy, let them close. If your thoughts are still wandering, let them go where they will. Tomorrow will come in its own time. Morning light will find you, and the clocks will resume their counting. But for now, you have reached a quiet shore. Thank you for sharing this little voyage. Thank you for giving yourself the gift of a moment unhurried, unmeasured. Time may be elusive, but right now, here in this breath, it is simply you, and the hush of rest. Sleep well, wherever and whenever you are,